At a certain temperature, the equilibrium constant K equals 0.11 for the following reaction. What is the equilibrium concentration of iodine monochloride if 0.75 moles of iodine and 0.75 moles of chlorine are initially mixed in a 2-liter flask? So one of the first things that I like to do for a problem is write down my governing equation, and how I'm going to solve this problem is using this equation. So this is just my equation for K. And this equals my concentration of iodine times my concentration of chlorine over my concentration of iodine monochloride squared. And this is squared because the stoichiometric coefficient for iodine monochloride is 2. So now that we have that, the first thing I'm going to do is find the concentration of iodide and chlorine initially. We are given information to find this because we know that 0.75 moles of each is initially mixed in a 2-liter flask. So the concentration of iodine initially is going to equal the concentration of chlorine initially, which equals 0.75 moles over 2 liters, and this will give us units of molarity, and this equals 0.375 molar. So now that we have that, I'm going to set up an ICE table to find the equilibrium concentration. So I'm not sure which method you all may be using to find equilibrium concentrations or that you've learned in class, but I think this one is incredibly helpful. So I'm going to start by writing out the reaction again. So I is my initial concentration that I have, and we just calculated that for iodine and chlorine, so we have 0.375 for each. And we don't have any iodine monochloride to start with. That wasn't initially present given our problem statement. So we have none of that. And then we're going to now represent the change in concentration by some variable x. So for both iodine and chlorine, we're going to subtract x because we're actually going in the reverse direction for this case. We have none of our iodine monochloride on this side. So in order to do that, we have to consume some of our iodine and chlorine on this side. So because iodine and chlorine are in a 1-to-1 stoichiometric ratio, we're going to subtract by the same value of x for both of them. And then again, following stoichiometry, we're going to add 2x to this side because this has a coefficient of 2. So our equilibrium concentration we just get by adding all of these terms. So our equilibrium concentration for iodine monochloride is 2x. Here we have 0.375 minus x, and again 0.375 minus x. So now going back to the governing equation that I initially wrote, we're going to plug all of this in to our formula for K to find what x is, because ultimately we want to know what 2x is, because the problem statement asks for the equilibrium concentration of iodine monochloride. So we have that K equals 0.375 minus x, and again 0.375 minus x over 2x squared. Again, this is squared because I'm following stoichiometry. And this just becomes 0.375 minus x over 2x, the whole thing squared, just to simplify it a little bit. And I will let you guys verify my calculations, but I get that x equals plus or minus 0.225. So for our x value to make sense, x must be positive. And that's because if we look at our ICE table, if x was negative, for instance, we would be subtracting away some concentration from 0 iodine monochloride because we had none initially. So that wouldn't make sense. So if you come up with two different values, it usually depends, which one you pick usually depends on which direction your reaction is going. So definitely go back and check your ICE table to figure that out. So now that we have our x value, we can find our equilibrium concentration of iodine monochloride. And that is just going to be 2x from our ICE table, which is 2 times 0.225 molar, which was our x value that we got. And that equals 0.45 molar.